Hi, today we're going to learn how to name some simple alkanes. So let's take a look at number 1. And the first thing we want to do is find the longest continuous carbon chain. All right, so let's see. Our longest continuous chain of carbons is equal to 5. So here we have a pentane. And now notice we have a substituent, a methyl group, on carbon number 2. So if we number from left to right, the methyl group is on carbon number 2. If we were to number the carbons from right to left, then the methyl group would be on carbon number 4. So we want the lowest possible number. So in this case here, we have a 2-methyl pentane. Let's take a look at number 2. So in number 2 here, again, we want to find the longest continuous carbon chain. And in this case here, that is going to be 4 carbons. Okay, so my longest continuous carbon chain, I'm just going to start here. That's 1, carbon number 2, carbon number 3, carbon number 4. And again, now I have 2 methyl groups, and if I number from left to right, the 2 methyl groups are bonded to carbon number 2. If I were to number from right to left, so let's go 1 here, 2, 3, 4. Our methyl groups would be on carbon number 3, but we want the lowest possible number. So our longest continuous chain, we had 4 carbons, so that is a butane. And we have 2 methyl groups on carbon number 2. So we're going to have to use the prefix di to show that there are 2 methyls. So we have a dimethyl butane, and we have to use numbers. So in this case here, we have a 2, 2 dimethyl butane. So yes, even though the methyl groups are on the same carbon, we still have to indicate the carbon number that each methyl group is bonded to, even though they're both bonded to carbon number 2. Let's take a look at number 3. We're just going to find our longest continuous carbon chain here. And let's see, that'd be, I'm going to start numbering here, 1, 2, 3, and 4. So again, I have a butane. And let's see, if I number from left to right, I have a methyl group on carbon 2 and a methyl group on carbon 3. Let's try numbering the other way. We'll make this carbon number 1, 2, 3, and 4. So the same here. When I number this way, I have a methyl group on carbon 2 and on carbon 3. This molecule is symmetrical, so that's going to happen. So no matter which way I number it, I still have a methyl group on carbons 2 and 3. So what I have here is I have to indicate the location of each methyl group, so carbons 2, carbon 3, and I have 2 methyl groups, so I have to include the prefix di. So this one is 2,3-dimethyl butane. Now, let's go to number 4. Number 4 looks a little more complicated, but it really isn't. So here we have our line structure, and I'm going to go ahead and number the carbons from left to right. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now remember these right here are methyl groups. So when I number from left to right, I have a methyl group on carbon 2. I have 2 methyl groups on carbon 3. and 2 methyl groups on carbon 7. So let's just go ahead and write those numbers down. So 1 on carbon 2, and then I have 2 methyl groups on carbon 3, and then 2 methyl groups on carbon 7. So this is a 2, 3, 3, 7, 7. And let's see. Let's go ahead. Let me change colors here. I'm going to number in the other direction. So we'll start here. So this will be carbon 1, 2, 3, 4, 5. Remember, we want the substituents to have the lowest possible numbers. So in this case here, now I have 2 methyl groups on carbon 2, and let's see, 2 methyl groups on carbon 6, so that'd be 6, 6, and 1 methyl group on carbon number 7. So I have a 2, 2, 6, 6, 7. So let's take a look at this. We have to examine these. So I look at the first location, and both have location 2. Okay. Now up here, the second location is 3, and here it's a 2. So what I'm going to do is I'm going to choose this numbering scheme here, because this gives us, again, we look at that second location there, and we have it's lower than a 3. Here we have a 2, and here we have a 3. Okay, so that's why we'll choose this. So we'll call this then 2, 2, 6, 6, 7, and let's see. So how many methyl groups is that? 2, 3, 4, 5. So that's going to be a pentamethyl. Okay, and let's see. We had 8 carbons, so that's a pentamethyl octane. So we have a 2, 2, 6, 6, 7 pentamethyl octane. So that one was a little more difficult. We had to put some more thought into it. But again, the important thing to remember here is we compare the first location, and then when comparing the second location, again, the 2 comes before 3. So we choose this here. So let's finally go to number 5. And let's see, my longest continuous carbon chain has 3, 4, 5, 6, 7, 8 carbons. So what we have here is an octane. Okay, so we have our octane. And let's see, let's go ahead and number from left to right. And let's go ahead and number them from right to left here. So that becomes carbon 1, 2, 3, 4, 5, 6, 7, and 8. All right, let's continue to name this. Well, when we number from left to right, we have a methyl group on carbon 3 and an ethyl group on carbon 6. When we number from right to left, we have an ethyl group on carbon 3 and a methyl group on carbon 6. We're going to give ethyl the higher priority, and therefore we'll assign that a number 3. So in this case here, what we have is 3 ethyl, 6 methyl octane. Let's take a look at number 6 here. What I did, this is the structure that you're given, and I redrew the structure. And the reason why, if you look at this carbon here, it has two methyl groups bonded to it. And the same with this carbon. It has these two methyl groups bonded. So it's a good idea, especially when you're a beginner, just to draw out the whole structure, okay, and get rid of these parentheses. So that's what I did. I show this carbon with the two methyl groups and this carbon with its two methyl groups. So now what we want to do is find the longest continuous carbon chain. So, well, let's just try some different ways. I'm going to start here, and let me change colors. Let's start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. If I count across here, I'll have 9 carbons. I have a feeling we can squeeze another carbon out here. So how about this way? So let's start numbering here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it looks like our longest continuous chain of carbons contains 10 carbons. So that would correspond to decane. And now let's take a look at the substituents. Numbered this way, on carbon number 3, I have an ethyl group here. And on carbon number 5, I have this methyl group. On carbon number 7, I have this group here, right? And let's see, on carbon number 9, I have a methyl group. So the way it would be numbered would be 3, 5, 7, and 9. So let's go ahead and put those down. 3, 5, 7, and 9. Let me try numbering in the opposite direction because I want to make sure that I do have the lowest possible numbers. So here, I'll start here and number that is 1, 2, 3, and let's number this one as 4, 5, 6, 7, 8, 9, and 10. Now, numbering this way, that gives me a methyl group on carbon 2 and this propyl group on carbon 4. So I have 2, 4, and then carbon number 6 has a methyl group, and then carbon number 8 has an ethyl group. So we have 2, 4, 6, 8, and so this is what I want to go with. I look here at my first location here, and it's on 2, and here it's 3. So we'll have to go with this numbering scheme here. So let's go ahead and name this. So what I have is a 2-methyl, and I have a let's see, a 4. Now here's a propyl group, but see how the propyl group is attached. It's attached by that center carbon. So this means that I have an isopropyl. So I have a 4 isopropyl. And then on carbon number 6, I have a methyl group. And then on carbon number 3, on carbon number 8, I have an ethyl group. So remember, when naming these, we have to give alphabetical priority, in this case to the ethyl group. And so the correct way to name this would be, we have an 8 ethyl, and we have a 4 isopropyl, And we have a methyl group on both carbons 2 and 6. So I have a 2, 6, and that's going to be a dimethyl. Let me erase this here. Sorry about that. So that's a 2,6 dimethyl decane. So again, note when actually writing the name, remember, even though the ethyl group is on carbon number 8, it has alphabetical priority, so it comes first. And then the isopropyl, and then our 2,6 dimethyl.